Hello friends, सबको नमस्ते. So today in this video we extract dominant color from an image using K-mean clustering. Okay, so let me show you. For example, suppose this is the image and we want to extract top 5 dominant color in this. So this is out of top 5 dominant color which is used in this image. So let me explain you this code line by line so that we can get to know how it's working. So this is, you can say, these are the package which we use it, and you can say here we using NumPy and CV2. Now, okay, this is not here, this is not there. So here you can see, first we read the image. We have multiple 4 images are present here. We are using 4th image here. Then we convert that image to RGB. After converting image, you can say first we want to know the shape of the image. After that, here we are reshaping it into in which reshaping image to 2D array of pixel and into 3. Okay, means number of pixel in divide into have 3 number of pixel with 3 column in it. Okay, so here for that, how we can do it, just image.org.reshape image.shape, then 0, then shape 1, and 3 column will be there. This way we done it. Then you can say here image shape is image shape will be 642 and this, and here when I print the length of the image, means this image, if I print the length of this image, this is not so okay, sorry, length of this image after reshaping into 2D, the 3 column RGB column will be there. And you can say, let me also, one thing I want to add it here, I want to print the image also. Means after changing how it's look like, it will be the 2D array. Okay, but not here. I want to print it here because it's disturbing. So Control plus X, and here. Okay, see, let me run it now. Okay, see what is happening here. Initially it is the image converted into RGB. After that we have to know the shape of the image. After that we convert that image into reshape that image into image.shape 0 in multiply by 0, 1 and 3. Means 3 column will be there, RGB column will be there. How after reshaping it, image look like, it's look like this. Means every pixel's value have RGB 3 column, and these are the pixel list, you can say. And after that, what is the length of this image, how many pixels are present, it's present 657408. And after multiplying image original, means this shape converting 0 into multiply by dot 01, means height and width multiply it, number of pixel remain the same. So here we convert the number of pixel into this list, pixel list in 2D format. And here this column is act as R, this column act as blue, and this column act as for the, sorry, this column act as green, and this column act as a blue. So this is RGB column it is. Now main thing is happening, how many dominant color we want to know inside the image. Initially I want only 5 dominant colors, so that's why initial its value 5. I can choose it 4, 3, it's up to me, but I want 5 dominant color from the image. Then just create the k-means, initialize the k-means. How, from where we importing it, we are importing as from Scikit-Learn cluster the import k-means. After that, just pass the number of cluster which you want, means how many number of dominant color you want. After that, just fit the image. After fitting the image, is provide these things: clt.labels, length, clt.labels, clt.cluster center. Okay, so let me print this all. Our first is clt.labels. What it's this is, okay, where it is, see, this is cluster labels 002222. What it is me, what is this, this is that it's, suppose this is your first pixel. So here this first pixel, this first pixel is you can say label as 0. The second pixel label had 0, third pixel label as 0, and this is somehow pixel 1 pixel whose label will be 2, and this label whose label will be 2. So this way it label each pixel which we pass here when we pass the image here. After that, what is the length of this label, it should be the same of the image. Okay, says 3657 657,408, 657,408, same length, because it label each pixel which we have passed. Okay, what is then what how I want a cluster centers. Okay, means I want the dominant colors RGB value, means I want those. So how we can get it? This is the clustered or cluster CLT or cluster center. It's give me this it give me the list of 5 cluster center. These are the dominant 5 color in the image. These are the RGB values of those. So for your explanation that this is your okay, this is first you can say first color, then its value will be 96, 90 and 60. Let me show you 90. Okay, let me open it. 96, 96, 90 and 60. 60. You can see this color is matched with this. So it's provide me this, but it's provide me 5 dominant RGB colors values, pixels value. Okay. Now if I take one color also, so it's suppose I take this one, third one, 37, 53, 8. 37, 53, then 8. It's give me this color, and you can see it's similar to this one. Okay, so this way we get a color. Now why we want histogram here, what we want histogram here, what it is, why we need it. So see what is why we are using histogram here. K-means give 5 RGB color values, means dominant colors. These color represent the dominant color in the image, but this does not tell which color appear the most, means which color is appearing the most in the image. Okay, it does not tell me. Okay, it also does not tell which color appear the least. Okay, it does not indicate which color belong to background. But so cluster central tells what color exit, not how much each colors appear. Okay, so this is what k-means give me. K-means just give me dominant colors, but does not tell me that which color is the most, which color is the least, and which color is for the background, and how much value, means how much value it does not tell me. K-means does not tell me, just it just give me dominant color RGB value. So how we can get to know that which color is dominating, means which color is most in the image. For that purpose we use histogram. So we just pass the CLT in the centroid histogram. Okay, in this centroid histogram we're passing it. After that, this is a cluster labels. Okay, you can say cluster label, we're just passing the cluster labels contain the cluster index 012 for every pixel. I already tell you what's the meaning of that cluster labels. After that, I want to know how unique values present in that label, so I have printed it. So you can see it, you can see a different label will be 0 1 2 3 4. Okay, because five dominant color to 4 for the fifth one and 3 for the fourth. So this way five you can say 0 1 2 3 4 index values are present, and max cluster. Okay, so count total number of unique cluster. If k-means was set to 5, this should be 5, means how many unique labels are there. It give me number of cluster will be 5, its value will be 5. After that we want to for in histogram we pass 2 parameters. Okay, in histogram we have to pass the 2 parameters. So first one is labels, means all the labels we have to pass, and second thing is the bins. We have to create the bins. So here we have to create the bins, but how much bins we have to create for this is the meaning that create histogram bin from 0 to number of clusters. So how many number of clusters we have? 5. So it will create for 5 cluster bins will be 0 1 2 3 4 5. So this way it's create the 5 bins. Number of cluster from 0 to number of cluster plus 1, and you will get confused that number of cluster is 5 only, but so why this 5 is included? It's not included, it's excluded here. Okay, so don't worry about it. So bins is this one, because in bins when you put the range, so last value will get excluded. If suppose I give the range 0 to 256, so 0 to 255 is included, but 256 is excluded that time. Okay, And here just to, for now we want to know the histogram, means how much is the pixel value. I want to know the frequency of that, so that's why we use np histogram that parser labels, means this one, and the okay, and then the bins which we have created. So how many pixel belong to each cluster. So okay, this tell me how many pixel belong to each cluster. It's give me number of, it give me the frequency for each, you can say for each cluster, for each cluster you can say, or for each dominant color. Now I have printed before float, after float, and after. What is happening here? This is just you can say I'm changing the float type. What is happening here? Now I get a frequency, number of pixel value representing that particular color. I know the frequency, but I want to know the in percentage. So how we can do that? Just divide each cluster count by total number of pixel. This give percentage contribution of each color. Okay, this way we do that, and after that I have also printed it, and I also at that I have written the hist. Now let me see before float, after float, and percentage. See that. So histogram before float, it looks like this. Means uh, means each pixel 657. Okay. So here histogram before float give me that first it means this color number of pixel value will be this. For this color number of pixel value this, so means it give me the frequency, and when you add all these you will get this value. Let me show you. This one I have already calculated. So after adding all that values, frequency values, I get this 657408, and it's already the number of pixel which we have. So this way we get it. After flotation it will give it get a points value, but after percentage, for percentage it will be this value 0.26, means it's 26 percentage, and it is 18 percentage, it's 22, it's 16, and it's 15. So oh, this way I get the percentage. Now how we generate this bar? For that everything is happened, means main thing is done. Now we have to do the generate the bar. For generating the bar we use this function plot colors, and here we just passing the, see what we are passing here. We are passing the histogram which we have calculated with the frequency percentage, and we're just passing the cluster cl to the cluster center, because this give me the rgb value. So here we can draw the color. Okay, so here we get this histogram, then the centroid bar height. You can say bar height will be 100 and bar width will be 500. So you can see bar height is 100 and bar width is 500. Okay, the bar width will be 500. So how we can generate it? We first generate an empty image for color bar height, and according to height bar we generate the mp bar of mp zeros height width in channel 3 channel will be the rgb, data type will be unit 18. Now starting x will be 0, starting position for first color block. For first color block starting x will be 0. Now we zip over histogram and center, because at same time it give me the frequency, and no frequency, not percentage frequency, and the centroid at the same time. So for the first iteration I get a rgb value also, and the histogram will and a frequency percentage for that particular rgb value I get it. So the end x will be that will be start x plus percentage multiplied by the bar width. Okay, this give me no, I will normalize that percent value, and I will add by the start x, I will get the index value. Okay, you can say that. I also printed the index value for particular this, for this RGB value. This is a you can say the index, and for this RGB value this will be the index. So this way we calculate the index value for per RGB value. After that draw the rectangle for current dominant colors. So we draw the rectangle. What is the starting point? Starting point will be int start x, means this one, and 0, and ending will be in index, and this is a bar height. This is, you can see, the coordinates value which will help us to draw a rectangle in that particular bar which we have created using this bar. And here bar is act as an image. -1 means we want to fill that particular area with that particular color. And which color? This is a color. Color dot s type united to list. Okay, it's choose the color like here. Now after that we get a, now starting Now after that we have to update the star text. So here we update the star text to is equal to index, and we have to return the bar. So this way we get the bar. Now we have to plot it. For plotation, just we have to plot out two images, original image and the bar. So this way we get it. Here basically x in 2D format. This is after reveal it convert into 1D format. Here just we draw the plotation with the title. Okay, so this way we draw the title. Now you can see, let me run it now. Let me run all thing. And you can see this is RGB here. Index value will be 133. So it's will be 133, 277, 277, 303, 303, 416, 416, and 498, 498. So this way the values are calculated. Now I want to know. I want to know this dominant five dominant color. Let me show you one thing also. If suppose I press it, I use it. I want only four dominant colors. Using cluster K-means cluster, I want to know only four dominant colors. So let me run it now. Only four centroid will be there, and everything remain changed. So it's taking time to run. So wait for it. So it's changed now. You get only four colors with dominate with their values. Okay, this way it's working. Now let me do something. Now let me come back when I want to I come back with some changes in the code so that I can plot all four images dominant for dominant color value with that. So let me do it. So this is 5. Let me pause. So I have made some changes here. Image folder, this one. Then I will read all the images file present in particular directory. Then I will iter over it. I want to know the image path, so just image folder and a file. I get the image path. Then everything remains the same. So this way I get it in this particular image. Dominant colors are this 5 colors are dominated. In this image, this 5 colors are dominated, and in this five, in these are 5 colors which are dominated, and this in these are 5 colors which are dominated. So this way we generate the dominant color from the image using K-means cluster. I hope I have explained you each and everything line by line and cleanly, and hope you will get some knowledge from this video. So please like, share and subscribe my channel. Thanks to all.